Hello friends, today we are going to present on IBM Watson.
This presentation is going to be broken down into 4 phases. We'll first talk to you about the history of IBM Watson, then how it works, the decision-making process, and finally we'll do a little look into the future.
According to IBM, Watson is an efficient analytical engine that pulls many sources of data together in real time. It discovers an insight and deciphers a degree of confidence. It is a supercomputer which is made up of 2,800 powerful computers tied in a highly connective network. It has a memory of over 15 trillion bytes. It was named after IBM's founder Thomas J. Watson, and this project is led by Dr. David Ferrucci. So now let's have a look at the Watson's life. Watson is basically a computer running software known as Deep QA or Deep Question Answering. It is a computer system that can directly and precisely answer natural language questions over an open and broad range of knowledge. It was formerly designed to take part in a quiz series called Jeopardy! Grand Challenge to defeat the world champion Ken Jennings. While the Grand Challenge driving the project was to win on Jeopardy!, the broader goal of Watson was to create a new generation of technology that can find answers in unstructured data more effectively than standard search technology. So, now Watson is used by IBM to perform data analysis and provide data-related solutions to the organizations in various fields such as healthcare and financial services.
The idea behind IBM Watson is that it uses cognitive computing instead of rigid coding. This allows for putting data into context and understanding unstructured data. In order to do that, IBM Watson uses what is called a corpus of knowledge. That is all of the information that IBM knows and can put into context, into fields, in order to make proper decisions. That corpus of knowledge can be broken down into kind of 4 phases of how it learns, because it needs to understand what is proper data, what is improper data, and what is necessary or not. So the first phase is learning the language of the field. That is in a very simple way. If I say something is blue, I'm referring to the color. If I say I am blue, that means that I am sad. Different words and different expressions have different meaning depending on how and why you say them, depending on the context. So IBM Watson does the first step of understanding the knowledge, the expression, and everything related to the field it is meant for. After that, there is something called curating the content. That means that if you have all of the information about medicine and you're only looking into cancer, there are some information that are not going to be relevant, whether they are outdated, they are just wrong, they are not scientifically proven, or they're not related directly to the type of cancer that is being used or looked at that time. That is creating the content. It's done both by IBM Watson and by experts in the field that helps it define what is important information and what isn't. The next step is ingestion. Ingestion is the idea that once you look at cancer and you have everything in that field, well, cancer is a big word. There is multiple types of cancer. So you kind of classify them and you make smaller categories. And for example, with cancer, a treatment that is good for one person might not be good for another. So ingestion is really categorizing all of the information and trying to make them relevant for particular situations. Finally, there is machine learning. Experts from all around the world put data into IBM Watson that they already know the answer to. And IBM Watson learns to know what the appropriate response is. Through learning and getting the answer correct more and more, they get to be able to infinitely continue to learn as well as getting more and more correct answers.
Now, let's have a look at the Watson's decision-making process. It is basically a four-step process in which Watson understands the problem and tries to come up with the best solution. Step 1. Question analysis. Watson understands the question by breaking down the sentences into phrases. It just does not look for the keyword matches like a search engine. Rather, it tries to read and interpret the text like a person by breaking down the sentences grammatically, structurally, and relationally. It tries to understand the meaning through the semantics of the language. It tries to understand the real context of the question and the intent of the person. Step 2. Hypothesis generation. Watson generates a hypothesis by scanning through the myriad of data such as knowledge articles and information blogs. It then finds out the probability of the correctness of an answer. Step 3. Hypothesis and evidence scoring. After generating a hypothesis and finding an evidence to support it or refute it, Watson scores each passage based on a statistical modeling for each piece of evidence. This is known as weighted evidence scoring. Step 4. Final merging and ranking. Watson merges the most correct and reliable answers together and rank them on the basis of their evidence score. During this process, Watson is able to run data analytics against a body of data and gain insights into it, thereby ensuring that it provides the best possible solutions to the humans, which in turn helps the humans to make a better and more informed decision. This entire process takes a time of 3 seconds.
With the combination of its corpus of knowledge and its decision-making process, IBM Watson has some great advantages. Some of them are to accelerate research and discovery, to anticipate and preempt disruptions, detect liabilities and mitigate risk, recommend with confidence, scale expertise in learning, and finally, enrich interaction. The current focus for IBM Watson are the field of health, research, cybersecurity, communication with customer, and maintenance. However, since there's constantly learning, there are way more applications that IBM Watson could be used for in the future. Could you think of some?
Here is a list of references. Thank you.